Alright, 10b is identifying domain, range, zeros, and intercepts of the function, algebraically and graphically. We're going to mainly focus on graphically here. So the definition is just a recap of what a domain is. It's representing all of the x values. So when you have a continuous function, this becomes very difficult to label all of them, so we tend to go from one side of it to the other, labeling all the x values, left side of the graph to the right side. The range is all of the y values. And we tend to write these very similar to how we wrote increasing and decreasing. Zeros are x-intercepts, where graph crosses the x-axis. Intercepts, you have x-intercept, which kind of speaks for itself, where the graph crosses the x-axis. And you have y-intercept, where the graph crosses the x-axis or y-axis. Now you may think to yourself, what's the difference between 0 and an x-intercept? Well, x-intercept is to be written the number, so wherever it crosses the x-axis, so it's written as a coordinate. The y is always 0. When we say 0, it's implied that y is already equal to 0. So we're just going to write this as x equals a number. So you just write the number down. So let's jump right into the problem. So the first problem, we have a quadratic, and we're going to do domain. Domain are the x values. So the left side of this graph keeps on going to the left. As it's going up, it's going to go left forever and ever. This is going to continue in this direction forever and ever. And ever and ever to the left is coming from negative infinity on the x values. And it's a continuous graph, and it'll continue to go to the right forever and ever. So our domain is all real numbers, negative infinity to infinity. You can write it this way, or you can write it as an inequality. Negative infinity is less than x, it's less than infinity. Now range is the lowest y value to the highest y value. So a domain is the lowest x value to the highest x value in the negative infinity and infinity. Range, so we always start at the lowest part of the graph. So in here we have a minimum point. This minimum point looks to be the y value is there at -1. So this point here, the y value is at -1. So that's the lowest part, -1. Because it's an actual point coordinate at -1, we're going to use, if you're going to use interval notation, this is a closed bracket, meaning that it is included in on the range. So there's an actual point at -1, and it's going to go to, so the lowest point's at -1, and where's the highest point? They keep on going up, up, up forever and ever, so that's infinity. The reason why we do not use a bracket instead of a parenthesis is for infinity. Infinity is not a number. It goes on forever and ever. So infinity has just a parenthesis, where if it's an actual point that's included, you put a bracket around. Zeros, we're going to write, that's -5 and -3. So x equals -5 and -3. Yeah, intercepts, x-intercepts, -5, 0, and -3, 0. And the y-intercept, so this is x-intercept, y-intercept. This graph we're going to have to, it's not perfect, but we're going to have to estimate it. So at 9, 10, let's say 12. So it's at 0, 12. That's estimated. It's off the graph. All right, example 2. Domain. So domain is the x values, so this is coming from the left, which coming from the left is continuous from the left, so it's negative infinity, and it'll continue on to the right to infinity. So again, the domain is negative infinity, which is to infinity. And the range, so what's the lowest part of the graph? Well, this part has an arrow that goes down, so lowest part, there is no lowest part, so it's negative infinity. And what's the highest part? So we don't pay attention to these local minimums and maximums here. The highest part is this, that's pretty bad, but it's the arrow that keeps on going up, 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 and it's going to keep going up forever to infinity. The zeros, let me erase what we got. The zeros in this case, there's 3 of them. Let's kind of estimate them. That one looks like it's kind of at -1. We'll say 1 and 2.5. So we got x equals -1, 1, and 2.5. I estimated those, so don't in class don't be alarmed if you have to estimate. X-intercept -1, 0, 1, 0, and 2.50. The y-intercept, again, let's estimate it. Looks like the y-intercept where across the y-axis is in between the 2 and the 4, so that's at 3. So 0, 3, write them as a coordinate. Alright, domain of a function. Now I don't have a graph, so what do you do when you don't have a graph? Let's put it in the calculator. And so I put it in the y equals, what, log of x minus 1, if you want to know where log is, it's right next to the 7. We go to graph it, and we get this. If you want to zoom in, I kind of want to zoom in and see what's going on here. Alright, from the beginning of the year, you might have to remember a little bit about log. Log functions do not have like a starting point. That's a radical function that has a starting point. Log function continues down. It has an asymptote. The asymptote runs right along this little tail down here. So the asymptote's right at 1. So that we got to think of that when we're doing domain and range. So the domain of this function, there's no parts of the graph are to the left of 1 on the x. So there's no domain there until we get to 1. So the domain starts off with 1. We don't include 1 because there's an asymptote there. So it's just to the right of 1, and it's going to go off to the right forever and ever to infinity. So it starts here just at 1. We don't include it with a bracket because it's an asymptote at 1. And it goes on to the right to infinity. Range. So this part, you have to know the graph isn't very accurate when it's drawing this. Range, the tail of this log function goes down forever and ever. So the range starts at negative infinity, and it'll keep going up and up and up as it goes to the right forever to infinity. So the range in this case is negative infinity to infinity. Let's look at the x-intercepts, or zeros. Second trace, 0, left bound, hit enter, right bound when it's asking that. Go to the right of the x-intercept. We're trying to find the x-intercept 0. Enter, guess, enter, 2, 0. So x equals 2, which means the x-intercept is 2, 0. So I'm just trying to get you to realize that zeros, you just write as a number. X-intercept, you write as a coordinate. Y-intercept, look back at the graph. The graph has an asymptote at 1, so therefore the actual graph cannot cross the y-intercept, so there is none in this case. Alright, that ends our video, but if you'd like to continue and try a problem, here's a problem to try. So you can pause this right now, and I will have the answers for you in just a second. So here are the answers. Domain, negative infinity to the left, infinity to the right. The range goes, both sides go from negative infinity, and they go up to 0, and 0 is included. It's a point that's included, so we put the bracket on. 0, -2, x equals -2. The y-intercept is 0. I estimated at -1. It's probably a little bit more than that, but -1.2 or something, but that's fine. I'm not going to be, the graph's never perfect, so you're estimating always anyways. X-intercept is -2, 0. Come to class with any questions. Thanks.